So the integral of that monster. Whoa, what's going on there? Do we think? You can see it, can you? It's not too small, the writing.
Yeah, no, I can see it. Yeah, it's good.
So the integral of that big fraction. Wow. So if we do suspect chain rule first, shall we? Maybe. I mean, I'm not sure why that might be chain rule. I mean, if the inner function were sine x or sine squared or the whole of the denominator, maybe. What's the derivative of? Yes, it's beginning to work out that way. So yes, I think even by inspection, we could just, and I would prefer to do this by inspection, actually. Oh, I'm a hypocrite, aren't I? I keep saying whatever works for you, you tell me, but I can't help wanting to recommend passing this as the result of a chain rule differentiation. So if we've got an outer function and an inner function, what do we suspect is the inner function? The u.
Yeah. Inner function is just going to be sine x.
Say again, yeah.
Can I just put it as sine x? Yeah.
What? Okay. I mean, as you know, whether we call it u or blob, as I tend to, or whatever, it'll take some pains, some trial and error, probably. I think, but here we're going to find that we're in trouble unless we choose u as anything smaller than 4 minus 8 sine squared x. And say, okay, it's basically 1 over that is what we're dealing with.
Yeah.
So the inner function is that, and the outer function we suspect is 1 over. We haven't dealt with that, that's true. What's that about? 4 sine x cos x. But because we're working through the chain rule, we suspect that that's going to be taken care of.
Yeah.
If we're going to write u equals 4 minus 8 sine squared x, yeah. Again, we're ignoring the other stuff. We're saying, oh, that'll be taken care of in a minute, we're sure. Because when we do du dx, yes, what do we get?
So you get minus cos squared, minus 8 cos squared x.
There's a little bit more to it. So let's look at that. So we've got 4, and you're right, that differentiates to 0. We ignore that. But then what about 8? Well, we've got a composite here. So we're squaring signs. So yeah,
so there'll be a third and a half and a.
Well, we're differentiating at the moment, not integrating. Yeah. So we're saying we're going differentiating. So we'll
10 times 2 and minus 1.
That's right. So 2 8s are 16, and then 2 minus 1 is 1. So we'll leave that like that. But then, of course, there's a u inside here, and this is another reason, really, to, you know, what are we going to do if we're going to be a slave to u substitution? Are we going to have another v now inside? But mentally, all you do is think, well, I know what the derivative of sine x is.
Yeah.
Derivative of sine x, cos x. So I know that's going to be spewed out on the way down.
Yeah.
So I know So I know that this is going to be taken care of.
Yeah.
So we could go through with the U process, but I just think it's overkill. We've just found out why it's, well, we could, we'll have basically minus 16 sine x cos x.
Yeah.
We could go through with that. But what about as a function of u now? What is that? Well, it's basically we're dealing with 1 over u.
Yeah.
So we know the outer function up here is going to be what? What's the integral of 1 over anything?
Ln.
Right.
Yeah.
So what we've got is ln of that. Whoa. 4 minus 8 sine squared x. And now we've just found out that, now we just do the sort of trial and improvement process. We say, okay, what does that differentiate to? And we know it's all of that, 16 sine x cos x. Okay, are we ready, or do we need a bit of an adjustment here? So that this equal sign is true. What adjustment do we need over here?
You need to divide the 16 sine x cos x by 4.
Oh, and by the way, that was minus. I forgot my minus there, didn't I? The four drops out, but we do need a minus there. So sorry, yes, because I was taking care of my typo, I didn't listen to you. Sorry, give me the adjustment.
Do you need to divide the 16, well, minus 16 sine x cos x by 4?
Yes. Yes. In other words, the whole thing needs to be multiplied by
Quarter.
a quarter, minus a quarter, sorry.
Minus a quarter.
In which case?
Then that equals that thing there. Yeah.
Are we done?
I'm not sure what else.
Can we just put plus c here? Does this fraction equals that plus c?
I'm feeling the answer is no.
Yeah, because we had to make an adjustment down here.
Yeah.
So,
yeah.
I mean, let's not forget that this wasn't the integral of all that. This was the integral of just that, which wasn't equal to that. So to make this equal to that, we had to say times minus a quarter.
Yeah.
But now we've changed to what's down here, so it will no longer be precisely the derivative of just log of that.
Okay, yeah. So you need to know what the integral of a quarter minus a quarter.
Ah, interesting idea, but then that would be on the misapprehension that the integral of a product would just be the product of two integrals.
Oh,
and it's simpler than that, really. The point is that if you know, if you've got a derivative dy dx, you know that's the derivative of y.
Yeah.
Well, what's the what is 3 dy dx the derivative of then? So, for example, I mean, x squared is the derivative of what?
For the third x cubed.
Yes, it is.
I think, yeah.
But what about 3x squared? What would that be
The other way. It would be just x cubed.
It would be x cubed because it would be 3 times the integral. Pardon me. that, wouldn't it?
Yeah.
In other words, you know, when you're doing calculus, whether you're differentiating or integrating, any constant multiple is just easy.
Yeah.
You know, the integral of 3 dy dx is just 3y.
Okay. Yeah.
The derivative of 3y is just 3 dy dx. Simple
Yeah.
as that. Okay. I mean, you could check that by using the chain rule, in fact. But if we just take that, because that's probably just reminding you, you were aware of that, weren't you? Anyway, when you do in differentiation, oh, I've got 3 times that. It will be 3 times that down here.
Yeah.
So
Yeah.
the point is that this adjustment we had to make here is less consequential than I think you were trying to allow for.
Okay.
I
Yeah.
mean, the effect of that is just simpler. Having multiplied the derivative by minus a quarter, the only adjustment we have to make up here is
Timesing it by a quarter.
minus a quarter, yeah.
Minus a quarter.
Yeah. And then we're done. So the derivative of, the integral of this fraction, which is what this says up here, the integral of this fraction,
Yeah.
is precisely that, plus c.
Yeah.
Just need to move. Okay. And then we can check straight away by differentiating. If we don't believe it, if we're not sure. Say, okay, if we were differentiating that, how would we put that? Well, if we were differentiating, I've already passed it. But if we were differentiating minus a quarter log of this thing, and perhaps it would be plus any constant we liked.
Yeah.
So we would pass that by thinking, okay, well, we need to apply the chain rule because we've got an outer function and an inner function. And then this is what we would be thinking.
Okay. Yeah.
Log differentiates to 1 over. And then because it's such a composite, we apply the chain rule and multiply the result by the derivative of the inner function.
Yeah. Okay. Yeah.
So that is, I promise you, what they want us to do there. If you think, well, I want to use u, fair enough. Bear in mind that differentiating u involves the chain rule again. And you don't want to, that would be overkill, definitely, to use another, although you could. You could say, okay, I'll think of 8 sine squared x as 8u squared. And that's going to be 16u.
Yeah.
Kind of overkill, because mentally all you need to do is say, okay, well, I've got 8 of anything squared differentiates to 16 of the things, but then the inner function needs to differentiating for that purpose there.
Yeah. Yeah, okay.
Is that okay? Oh, and then having done that, of course, you could say, therefore, dx I can replace with dx I can replace with well, 1 over that, or minus 1 over 16 sine x cos x. And now if you put that expression into there, replace dx with that, oh, du, of course, then that'll just cancel and you'll just be left with the integral of minus a quarter, or rather minus 1 over 4u.
Yeah. Yeah, yeah, okay.
which you can go through with if you want, and just let me know at any time if stop this nonsense now. I want to do it with the U all the way through, but you'll find, well, it depends. You know, different people do it differently, teach it differently, but anyway, the moral of that is it can be done by inspection. And I think that's what they wanted you to spot in that exam. Was it a real exam? No, they just made this up for the book. But anyway, right, 1/3 minus 4x. That's a bit simpler. Integral of 1/3 minus 4x. Definitely by inspection. And what do we get?
It's going to be a ln.
Yes, good. You can see the structure of it. It's just going to be, so right away, just say, okay, what if it's ln of 3 minus 4x?
Yeah.
Does that work? Try differentiating that. What would you get?
You get
you see, it's ln of stuff.
Yeah, you say times then minus 1/4. No, times minus 4.
Yes. What times minus 4?
1/3 minus 4x.
1 over the same stuff. Yeah.
Yeah.
Okay. Well, that's no longer equal to what we were trying to integrate, which was 1/3 minus 4x. How can we make it equal again?
Want times the top by 1/4, minus 4, sorry.
Yeah. If you times the top by minus 1/4, then because of what we were just discussing, you know, we've multiplied by a constant, so the derivative will be multiplied by the same constant.
Yeah.
And now we've restored the lower level to exactly what we were trying to integrate.
Yeah.
The equal sign is true again, isn't it?
Yeah.
So there's your answer. Plus C.
Yeah. Sorry. Yeah. Minus 1/4. Yeah.
Okay. That's what you want to be thinking. But no harm or shame in doing a diagram to make it completely clear. And then you can, because you always want to check immediately by differentiating an integration.
Yeah.
So if you do a diagram, then you can differentiate straight away. Say, oh, check this. What would happen if I was differentiating that? Well, of course, I would say 1 over all of that multiplied by the derivative of the inner function. So, and then that would cancel this minus 1/4, and I would be left with this, which I was meant to be.
Yeah.
I was meant to, meant to differentiate to give me 1/3 minus 4x, pure and simple. So yeah, that's the integral of that.
Okay. Yeah.
Where was I?